In this video, I am going to discuss about centrifugal casting process. Centrifugal casting is a metal casting process that uses the force generated by centripetal acceleration to distribute the molten material inside the mold. In centrifugal casting process, a rotating mold is used. The molten material that is pouring inside the rotating mold, or otherwise, after pouring the molten material into the mold, the rotation of mold will be starting. As the mold is rotating, due to centripetal acceleration, a centripetal force will be generated. That force will distribute the molten material inside the mold, and that force will be remains there during solidification also. So that's the principle of centrifugal casting process. So in a centrifugal casting process, that may be a permanent mold casting process or expandable mold casting process. So in centrifugal casting process, a rotating mold is used. As the mold is rotating, due to centripetal acceleration, a centripetal force will be generated. That force will distribute the molten material inside the mold. So there are three types of centrifugal casting process. First one, true centrifugal casting process. Second one, semi-centrifugal casting process. And third one, centrifuge pressure casting process. So these three are the classification of centrifugal casting process. So we can discuss one by one. First of all, true centrifugal casting process. See, this is a figure of true centrifugal casting process. See, in true centrifugal casting process, mold is rotated by means of rollers in horizontal or vertical direction. During casting process, the mold is rotated by rollers in vertical or horizontal direction. So here rollers will be using for rotating the mold. Either it will be in vertical or horizontal direction. In this figure, the mold is rotating in horizontal direction. Molten material for the cast part is introduced into the mold from an external source. Molten material that is required for the molding process or casting process is introduced from the external source. The liquid metal that is flow into mold cavity, so this is a mold cavity. As the mold is rotating, the molten material that is pushed in outward direction towards the mold surface. So as the mold is rotating, the molten material that is pushed in outward direction towards the mold wall. So the rotation will be remains there during solidification also. So the molten material that will be stick into the mold wall surface. Okay, so this is known as true centrifugal casting process. See, during pouring and solidification phase, in true centrifugal casting, the forces play a vital role in casting process. See, during the pouring and solidification process, there will be centripetal force that will be created due to centripetal acceleration that always play a vital role in this casting process. See the magnitude of centripetal force. See, you can see this figure. This is a mold and this is a casting. So this is the axis of rotation. Okay. So the magnitude of centripetal force that will be increasing away from the axis of rotation. So here the magnitude of centripetal force will be less comparing to the magnitude of centripetal force that will be acting here nearer to mold 1. So you can see that the centripetal force, the magnitude of centripetal force that will be increasing when moving away from center of axis of rotation. So near the mold wall, there will be high magnitude of centripetal force will be acting over the molten material. So high density cast part will be created. In center portion, there will be less centripetal force will be acting. Okay. So what about impurities? The impurities have less weight when comparing to molten material. So the impurities that will be always accumulated near to the axis of rotation. Okay, the impurities have less density when compared to molten material. So what about the impurities means? The impurities will be always collected in the less denser region. So this is less denser region and this is high denser region. Why the density will be increasing here? Because in this region, large amount of centripetal force will be acting. Here, large amount of centripetal force will be acting because distance from the axis of rotation is large, more. So the impurities have less density. So the impurities will be always accumulated nearer to the axis of rotation in this region. Okay. That can be removed by further any grinding or any other machining operation. So this is a case of true centrifugal casting. Okay. Then second one is semi-centrifugal casting process. See, in semi-centrifugal casting process uses an expandable sand casting mold. Uses an expandable sand casting mold that is rotating. So this is the expandable sand casting mold which have two parts, cope and drag parts, and which is rotating by some method. So in semi-centrifugal casting process, the entire mold is completely filled with molten metal, which is supplied to the cavity through a central screw. So the entire mold is completely filled with molten material, which is supplied through a central screw. See, casting manufactured by this process always need a rotational symmetry. So this is the casting. During semi-centrifugal casting process, the entire mold cavity will be completely filled with molten material. The mold will be rotating. What will be happening when the mold will be rotating? This is the axis of rotation. So the centripetal force, that will be increasing. The magnitude of centripetal force will be increasing in moving away from the axis of rotation. So here high density region will be creating. Here also a low density region will be creating casting near to the axis of rotation, and the impurities that will be accumulated in this region. See why the impurities are accumulated in this region? Impurities have less density. So as impurities have less density, it will be always accumulated nearer to axis of rotation that can be removed by some method. So we have a high density casting will be produced. Okay. So this is semi-centrifugal casting process. For a semi-centrifugal casting process, the casting should always possess rotational symmetry. That's a very important one. Casting should always possess a rotational symmetry. And third one is centrifuge pressure casting process. Okay. See, this is a figure of centrifuge pressure casting process. See, in centrifuge pressure casting process, casting manufactured by this process does not require rotational symmetry. That's a very important point. Casting manufactured by this process does not require a rotational symmetry. See, in this process also using expandable sand mold that is rotating by some method. So this is a expandable sand mold which have core portion and drag portion. This is the core portion and this is the drag portion, and this is the mold cavity, and this is central screw and runner. So casting manufactured by this process does not require a rotational symmetry. See, the mold is designed with part cavities located away from the axis of rotation so that molten metal poured into the mold is distributed to these cavities by centrifugal force. See, these cavities are located away from the axis of rotation. and there is a central sprue and a runner which will supply the molten material into the cavity. So as the mold is rotating, due to centripetal force, the molten material is forced into mold cavities. And these mold cavities are located away from the axis of rotation. The centripetal force that will be acting over the material during solidification is high. So high density casting will be created. High density casting will be produced, and the impurities that will be located in the center portion that can be removed later by some methods. So this method is only used for producing small sized casting in large numbers. Okay. So these are the three methods of centrifugal casting process: true centrifugal casting process, semi-centrifugal casting process, and centrifuge pressure casting. So once more, what's the principle of a centrifugal casting process? In centrifugal casting process, the mold is rotating during casting process until solidification of the casting. Mold is rotating either in horizontal or vertical direction by using some rollers or other any methods. In centrifugal casting process, using either a permanent mold or an expandable sand casting mold. In centrifugal casting process, the centripetal force that is created due to centripetal acceleration, that is forces a molten material into the mold cavity. And the magnitude of centripetal force that will be increasing when moving away from the axis of rotation. So high density casting region that will be created away from the axis of rotation, and less density casting that will be created very near to axis of rotation. See the impurities that have less density when comparing to molten material. So impurities are always collected very near to axis of rotation, and also that can be removed by after casting process. The impurities can be removed. And these centrifugal casting process are three types, that is true centrifugal casting process, semi-centrifugal casting process, and centrifuge pressure casting process. Okay. Then what's the advantage of centrifugal casting process? Casting acquire high density, high mechanical strength, and fine grain structure. Casting have high density, high mechanical strength, and fine grain structure. Inclusions and impurities are lighter. So inclusions and impurities are always collected in the lighter section of the casting. See, gates and risers are not needed. High output. Formation of hollow interior without core. See, by using centrifugal casting process, a hollow casting that can be produced without a core. That's the important point. See, what are the disadvantages? An inaccurate diameter of the inner surface of the casting. See, the inner surface geometry and dimension cannot be achieved accurately, as there is no core will be there. It is only depend upon the centripetal force that will be acting over the molten material. Okay. Not all alloy can be cast in this way. We cannot cast all alloys by using centrifugal casting process. So what is the application? For casting pipe, bushing, gear, flywheel, etc. we are using centrifugal casting process. So this is all about centrifugal casting process. Okay, thank you.